idea was take a group of users sharing a trunk, look who's using the most at any point in time, and if the trunk is full, start whacking them and slowing them down. As Jim put it, what did you call that, Jim? The
Whack-a-mole.
Whack-a-mole. Sort of. So a new coin term for the product as of this morning is the automatic whack-a-mole product, and that's kind of what a NetEqualizer is. It looks for the moles as they pop up and whacks them. Now, the analogy is basically when does a mole pop up? Well, a mole pops up when they're using too much bandwidth and the network is congested. And if you can whack these moles fast enough, you keep your network from overloading, meaning gridlock. Now, gridlock is sort of an insidious thing because it's not just a the way a network operates with web browsers and whatnot is when your network peaks and everybody locks up, everybody's trying at the same time. You know, you just hit refresh on your browser and you're trying to bring up a page. What your browsers do is they keep retrying. So it's almost like a traffic jam where, you know, everybody tried to get on the freeway at once and it didn't work and they just keep pushing and butting heads against each other. So the gridlock period is exasperated and lasts for much, much longer. So in traffic control, you notice how they have these lights on the freeway where they put a red light so that it just doesn't happen. And so you still have traffic on the freeway and it's still pretty full, but you don't have absolute everybody stopped. And that is the exact analogy of a NetEqualizer. I don't have the math behind it, but basically, if you just keep it from getting completely stopped, you can allow a lot more people to flow smoothly instead of nobody. So it's sort of an all or nothing proposition. Our behavior-based shaping was, as people were discovering, people were just going, yeah, I plugged it in. It doesn't, yeah, we don't really know what's going on, but it's whacking the moles really good and it's keeping the traffic down. And so it doesn't really matter what the traffic is. It's if you see the behavior-based correlation between bad behavior and bad applications, there's a one-to-one matching, meaning somebody that's using a lot of data with peer-to-peer or doing large downloads or large email attachments generally should take a lower priority than somebody that's doing streaming audio, text messaging, just regular web browsing, short emails. Those are the Citrix is another one that comes up because that's in the business office and everybody says, well, my Citrix is the most important. Well, 99% of the Citrix traffic is really small. So if you give that relative priority over the big traffic, you've solved it. But it's a much, much simpler model. It doesn't take any expertise. It doesn't take ongoing engineering costs, which we pass along to our customers. And so we have a big price difference between us and them.
We came across the NetEqualizers and we're very happy. We don't have to spend the time to get everything configured and babysit it almost in the day-to-day operation. It just kind of sits there and does its job. It keeps the connections down, and we haven't got the complaints we used to get from students that this game's not working or this application's not working, this game is classified.
That's why the idea of behavior-based shaping works is if this network becomes really crowded, then you can see that this person has a disproportionate number because all these people are actively doing something, but they're using a very small amount of bandwidth. So if we steal from this guy, in the case of, maybe we're getting near that critical thing, that one person suffers a little bit on their download. Who knows what this is? This might be a big email attachment. They might suffer for a few seconds, but at the relief of everybody else. Hence the traffic jam is averted. Hogman at 12,000, that's the number, that's the threshold where any one of those connections we saw will or may not be slowed down in a critical situation. So if the network is congested, in other words, getting close to 200 meg, then the next thing NetEqualizer looks at is Hogman to say, is this connection a good or bad one? It's just a relative term. And 12,000 is a magic number because that happens to be where Skype and streaming audio cut off. So anything below 12,000, that's where Skype and streaming audio and VoIP phones would be usually below that. And anything above that is big. And if you just go back from memory from that other screen we looked at, it's sort of like everything's below. You saw a lot of small numbers and then bang, there's one big number. So it's no accident that we picked 12,000 because 90+% of the traffic is going to be below there. And that's the quick traffic. And so again, rather than try to figure out what somebody's doing, in other words, we don't really care what it is. We just know that most things an administrator would allow that aren't a problem would be below that, and everything else will be above that. Now, the reason why I'm saying you can bump that up, and this is sort of a philosophical question, do you think it's appropriate for, with YouTube being so popular now, is that something that you think you can afford to let your students, run with without getting delayed? Because YouTube is going to run about 300 kilobits a second, and that's going to get caught. Now remember, it's only going to get caught when the network's congested. So this morning in the dorms, students can probably watch all the YouTube they want, but if it gets crowded, we're going to cut back on it. And this is sort of the latest thing that we're running into with consulting with our customers is, YouTube has become a reasonably acceptable form of communication. It's not like peer-to-peer where it's all generally bad copyrighted material. So we're sort of between a rock and a hard place in that you got to have enough bandwidth to support it. Now, the interesting thing with 200 megabits is that if you raise this to 36,000, the YouTube will probably get through. And guess what? There's still a lot of other big stuff out there that's probably causing, big peer-to-peer downloads, large email attachments, large picture attachments. They're going to take, a T1's worth of bandwidth when they fire up. So you can still get some shaping in there. You might have enough bandwidth to do video at 200 megs in your dorms and raise that, but keep an eye on it. Nobody serves up these peer-to-peer files with any speed. They all go desperately slow. So what they do, if you're downloading, a Led Zeppelin or the latest bootleg movie or whatever, if it's a popular one, there'll probably be 10,000 sites with it on, available. And so what your client does is it goes out and tries to download simultaneously from as many sites as it can connect to. And that way, the reason being is that way it gets the file sooner, because otherwise it might take 12 hours. I mean, some of these connections are barely even dribbling data, and these are 10 meg files. But if you get 100 barely dribbling connections, it goes quickly. So what we used to see, as of last year, I would, some new ISP or residence hall would put an NetEqualizer in. They wouldn't really have started it up. We would go here and we'd see 100, 100, 150. We'd see half a dozen, and that was accounting for maybe 50% of their bandwidth on their network, all day long and night. So, and I just did one the other day where I had a customer that they had a hard limit on an IP address. They said, this person's downloaded 30 gig, and I have your hard limit on it, meaning our thing that's supposed to limit them to 500 or 64 kilobits. I don't know what they had, and it wasn't working. And they said everything else is working, but this one hard limit, your box is broken. It's just not working. So I logged in, and I did a count, and the IP address they were trying to hard limit had 150 connections. And I explained. I said, well, the hard limit isn't sophisticated enough to track. I said there's ways we could stop 150 connections cold, but if we designed our algorithm like that, it would have a lot of other bad effects. We'd have to do a lot of packet dropping. So we'll get to that in a second. But when the NetEqualizer tries to limit, if you just put a fixed rate cap on an IP address, we're trying to maximize smoothness without adding a huge cost to the hardware, because it takes a lot of overhead to sort of think ahead and figure out how fast do we need to buffer these packets. So we got a nice algorithm in there, but what broke it was 150 simultaneous connections trying to keep track of, and so they were still blasting through our hard limit and getting more data than they wanted. But if the customer had put a connection limit on, which is what, if you read through our start guide, we recommend both, putting a generic connection limit so nobody has an outrageous number of connections. And to date, the only thing that'll take, you can see out of, only 10 connections, there's only a handful of users out there, and you've got how many thousand people in the dorms. So the only things that take maybe more than 10 connections to sustain it are viruses and peer-to-peer that I've ever seen. So